Okay, hello everyone. My name is Ethan. Today we'll be working through Physical Sciences Grade 12 Paper 2 from last year, November. Um, so, diving straight into the multiple choice section, question 1. Which one of the following represents a straight chain saturated hydrocarbon? So, to answer this question, you can draw each answer out and see which one it is, but there is also a really quick formula CnH 2n plus 1 that allows you to quickly check if it is a saturated hydrocarbon. So trying with 5 carbons, n represents the number of carbons. So in our answers, we have C5 and C6. So let's just check both real quick using our equation. So C5H. So if n is 5, 2 times 5 is 10. Oh, my apologies. This is not plus 1. This is plus 2. So n becomes 5. So 2 times 5 plus 2 is 12. So this is H12. And we can see that this is not in any of our answers. So let's try C6. C6, n becomes 6. So 2 times 6 is 12 plus 2 is 14. And we can see from our answers that this is D. All right. So these equations are just really useful. It's much quicker than drawing it all out, and they're worth remembering. There's also equations for alkenes, for alkynes, and for other different types of organic molecules to quickly check if indeed it is that type of molecule from the structural formula. Moving on to question 2, which one of the following is a secondary alcohol? So let's just remind ourselves what a secondary alcohol is. We first have our COH, this is our alcohol group, a single bond between carbon and the oxygen. And then secondary just means that we have two other carbon bonds, two different chains, and a hydrogen. So this is a secondary alcohol. Um, with this in mind, let's try and see which one of the answers satisfies this criteria. You can draw each one out, but it's much quicker if you just try to visualize in your head what the molecule looks like. For A, we can see that our OH group is bonded to the first carbon. Carbon can only have 4 bonds to it. So definitely OH is bonded to the first carbon, and the first carbon is then bonded to these 3 CH groups, meaning it's tertiary and not primary, so it can't be our answer. For the second one, our OH group is not bonded to the first carbon. This carbon already has 3 other bonds and is bonded. This carbon has 3 other bonds and is bonded to these carbons, which represent a chain. They're just drawing it in brackets because they're trying to confuse you. But it's easy to see that this is actually a primary alcohol. So, yeah, our OH group is bonded to the last CH2 group in these brackets, which is then bonded in a chain to the other CH2 groups, and then finally the CH3 group. So, yeah, that's primary and not secondary. For C, they're really trying to trick us here because you need to realize that this is not an alcohol at all. It's actually an aldehyde. If you try to draw this out, you'll see that you have to draw it with a carbon double bond oxygen, which means it's no more an alcohol, it's an aldehyde, and therefore it is not our answer. So by process of elimination, we know the answer is D. You can draw it out and check, but it is D. Moving on to number 3, they're asking us for a hydrolysis reaction. What is a hydrolysis reaction? Well, it involves water. That's the first part. So already we can eliminate B. B does not involve water as one of the reactants. Water is in the product, but not the reactants. And D is out as well because there's no water at all. So it's between A and C. Now, a hydrolysis reaction involves some sort of substitution or breaking apart of a molecule. In C, we see that water is actually added to the molecule. So this is wrong. We can see that water was added to the molecule and nothing was broken apart or no substitution occurred. So C is wrong. And therefore, by process of elimination, A is our answer. Moving on to question 4. The question goes, hydrochloric acid reacts with excess zinc by the given equation, and they show us the different test tubes with the different reaction conditions. And then the question asks us to compare the initial rate of reaction in Y and the final volume, again, of the product hydrogen gas in Y. So let's dissect this question and take some of the pertinent information out of it. The first thing to notice is that we have excess zinc, so the limiting reagent is the acid. Next, what's the difference here? In test tube X, we have 100 milliliters of acid, and in test tube Y, we have 200. So there's more acid in Y. Also, in X, the zinc is in powder form, and in Y, the zinc is in lumps. So, with this in mind, we need to remember that the rate of reaction is very much controlled by the amount of surface area you have between your reactants, especially when you're dealing with a solid reactant and solution. So the zinc powder in test tube X will definitely mean that X will have a faster reaction rate, initially at least, than Y. However, test tube Y has more acid, and the acids have the same concentration. But test tube Y has more acid, which means since zinc is in excess, there will definitely be more hydrogen gas produced in test tube Y. So, with this in mind, we know that the initial rate of reaction in test tube Y will be lower, and the amount of H2 in Y will definitely be more. So, the answer is B. Moving on to question 5, the diagram below represents a mixture of two gases. It tells us that they're at some temperature and the container has a volume of roughly 1. They give us the reaction equation and now ask us to compare the equilibrium constant Kc. So let's just remember what the equation for Kc is. The equation for Kc is products or concentration of products over the concentration of the reactants. So I'm just using a bit of shorthand here, but they've given us the chemical equation. So plugging in for the actual given equation, our product is N2O4 over our reactant is NO2. Now we have this 2 in our chemical equation, and we need to account for it by raising our reactant to an exponent of 2. So what you can see here is that let's just plug in some imaginary number because the uh, uh, just some random number because the volume of the container is close to 1. We can say that the concentrations of our products are really close to 1 as well. So some number really close to 1, maybe 0.9 over 0.9 squared, right? Or any other number, just some number really close to 1. And what you'd realize is that Kc is definitely bigger than 0, but it's definitely less than 1 because of this exponent in our denominator. So the only answer that matches is D. Okay. So moving on to question 6. A reaction is at equilibrium in a closed container according to the following balanced equation. They give us the equation. The volume of the container is now increased while the temperature remains constant. A new equilibrium is reached. Which one of the following combinations is correct for the new equilibrium? So let's break this question down. We're given the chemical equation, but the volume of the container is increased, but the temperature remains constant. So what that means is Because the temperature is constant and the volume changes, there is a change in pressure. So if we remember our equation, PV equals N RT, if our volume is changed but our temperature is constant, then our pressure has to change. One of these three has to change. Okay. So with that in mind, what it basically means is that the concentration of O2 would stay the same, but there would be more O2 in the system. So if you remember Le Chatelier's principles, if the volume changes, then the system would want to uh, also expand with the volume of the container to match the conditions. So there's only one gas in this equation, and that's oxygen. So if the volume of the container increases, there would definitely be more gas. So the equilibrium would shift in order to release more oxygen. But because the temperature remains constant, the concentration of O2 would stay the same. So we know that concentration of O2 stays the same. But of course, we're releasing more oxygen. So although the concentration is the same, there's definitely more moles. So the moles increase. And by process of elimination, we can see that the only answer that fits is this one, and that's C. So the equilibrium constant doesn't really change because the concentrations all remain constant. And if you remember from the previous question, the equilibrium constant is related to concentration. All right. So moving on to the next question, question 7. Nitric acid and ethanoic acid of equal volumes and concentrations are compared. Consider the following statements below. So, what's important here is equal volumes and equal concentrations. Nitric acid is a strong acid which totally dissociates in water, and ethanoic acid is a weak acid that doesn't totally dissociate. So, let's keep that in mind as we work through this question. Consider the following statements. They have different pHs. This is true because, like I said, HNO3 totally dissociates, so you'd have a maximum amount of hydronium ions in solution, whereas ethanoic acid does not totally dissociate. So you won't have as much hydronium ions or H plus ions, which affect pH in concentration. So definitely one is correct. One is correct. Both have the same electrical conductivity. Again, this is wrong because for the same reason. HNO3 totally dissociates. So there's a maximum amount of ions in solution. Ethanoic acid doesn't do that. So there's less ions. Conductivity is a property related to the amount of ions in solution because the ions carry charge through solution, and that's electrical conductivity. So this is wrong. HNO3 would have a higher conductivity. Both solutions require the same number of moles of KOH for complete neutralization. Now, this is correct because they have equal volume and equal concentrations. So, yes, they would require the same amount of moles of KOH to neutralize them. So, this is correct. So, analyzing this, we see that the only answer that fits our criteria is C. Or let me use a highlighter to be consistent. Okay. Moving on to question 8. The apparatus in the diagram below is used for the titration of hydrochloric acid and potassium hydroxide. In a titration, the learner accidentally exceeds the endpoint. Which one of the following will be true for the titration mixture? Okay, so we have acid in the burette and our titration mixture, which means we start off with base and then we add acid. So they tell us that we've exceeded the endpoint, which means we've totally neutralized all the base and we're now adding excess acid. So there will definitely be more H plus than OH minus because there's more acid than base. And because of this, the pH will definitely be less than 7 because that's an acidic pH and there's more H plus. So with this in mind, the only answer that fits our criteria is A. Okay, moving on to question 9. The following hypothetical standard reduction potential state or relate to a galvanic cell. Okay. Consider the following statements for the galvanic cell. The EMF of the cell is 0.2 under standard conditions. So let's check, is the EMF actually 0.2? So there's a couple different ways you can like calculate the cell potential, but essentially it's usually easier to just say cathode minus anode. So in this case, you must remember that the cathode is usually a positive cell potential and the anode is usually negative. So we know that the top one is the cathode and the bottom one is the anode. With this in mind, we just say cathode minus anode. So plus 0.1 minus 0.1, which actually comes to 0.2. So yeah, the first part is correct. And then, like I said, the anode is usually a negative half cell potential, and it says electrode Y is the anode, which is correct. So that's correct. And it says X is oxidized. So what is oxidation? Oxidation is the loss of electrons, and we can see here that X is actually gaining electrons. So it's actually being reduced, it's not being oxidized. So this is wrong. With this in mind, the only answer that satisfies our criteria is B. So B is the answer. Okay. Moving on to the last question in the multiple choice section. Which one of the following half reactions will be the main reaction at the anode during the electrolysis of concentrated copper chloride? So at the anode, so what happens at the anode? The anode is usually oxidation. Okay, so at the anode is oxidation. Oxidation is the loss of electrons. So there's a nice little acronym to remember this, which is oil rig. So oxidation is loss of electrons and reduction is gain of electrons. So we know we're losing electrons at the anode, it's an oxidation reaction. So what does that look like? So copper chloride would dissociate into copper, it's actually like this, into copper 2 plus and 2Cl minus. So with that in mind, we can already eliminate majority of these reactions that involve water because there's no water in our system. And we just want to analyze A and D. So copper 2 plus 2 electrons going to copper solid. That is gaining electrons. And we remember we said gaining electrons is reduction, not oxidation. So this is wrong. And then at the bottom, 2Cl minus going to Cl2 gas plus 2 electrons. So this is a loss of electrons, which is correct for an oxidation reaction. So this is the correct answer. This is the oxidation we can expect at the anode. And that concludes the multiple choice section.